I'm Adam Baker with Cranfield University, with the PSC and the UK Space Agency. I'm here at the Surrey Space Centre with Dr. Chris Bridges, Senior Lecturer in Space Engineering.
Reader.
Yeah.
Oh,
Awesome. High five.
What more to go?
So what do you do here at Surrey, Chris?
So I'm an electronic engineer, and I mainly teach electronic engineering in our undergraduate programs and avionics in our space programs.
But a lot to do with satellites, really.
Yeah. I build a lot of payloads, and I try and do at least one every year or two.
Awesome. Thank you. We're here in Mission Control at the University of Surrey. Mission Control is where a number of different satellites are operated from. Chris, you're directly responsible for operating several satellites and have done others in the past. Why is space traffic control with regard to operation of satellites an important topic?
So space traffic management in general is really important because an operator has sort of typically legal ownership, and just like a car, you have to insure it, and you have to ensure then that it is also not a danger to others as well. And usually what happens is that a country will also be the licensee. So we would license a satellite. Say, for instance, if we built a nanosat for applications here, then it would also be registered in the UK. So even if, for instance, it was a company and that company went bust, the UK would then perhaps become liable for anything that then happened to that satellite. And dependent on the orbit, they can be up there for a really long time.
Okay, and what kind of things could happen to a satellite in orbit that you might be really concerned about?
So currently at the moment we're really concerned with conjunctions. We're really concerned with satellites then interacting with each other physically, but also in radio spectrum as well, so that they can then continue to then do the services that they do.
So, Chris, you've mentioned a couple of times something called a conjunction and things like relative speeds, and we were talking about M25s and sort of Park lanes. What's a conjunction in the space world?
So a conjunction is where two satellites' physical locations or boundaries of where we think their physical locations are intersect with each other. And usually this is important because a satellite will have an absolute position that we can look at in a given orbital reference frame, X, Y, Z, Cartesian, or as well as the classical orbital elements. The problem with that, though, is that there is an error associated with that. And that error is usually then in the form of an ellipsoid. So we have essentially, if you think of three ways that a satellite can travel, it has a long track, it has its radial component, or zenith, up altitude-wise, and it has its out-of-plane or cross-track motion. So the radial one and the one side to side, we know pretty well. Okay, so that has an error that we might measure in meters. And the problem is along the velocity vector where the satellite's traveling, that has a much bigger error. And so what we end up having is these weird ellipsoid shapes that then intersect with each other, where you think you know where a satellite is, but as soon as those things intersect with each other is where we start to perhaps get nervous.
And there's the possibility of a collision there where you've got greater and greater intersection in kind of like a three-dimensional Venn diagram, is that?
Yeah, if you think of it, these things are intersecting each other, and when these things, even if they're not close, the probabilities increase. And we start to get nervous, really. We kind of look at a conjunction happening at about 5 kilometres, gives you an idea of how big these ellipses are. We measure them, in sort of 5 kilometre ranges.
As I understand it, you're interested in working with and possibly controlling and getting data from multiple small, low-cost spacecraft here at the University of Surrey. So how important are conjunctions to you on kind of a day-to-day basis for what you do?
So conjunctions happen fairly often. We get a number of warnings from the Joint Space Operations Centre, JSPOC, which is the sort of big radar station that is run out of the USA. And what that will do is it will tell us, for instance, what it believes to be our predicted minimum between two objects are. And so usually what happens is we will get an email from the Joint Space Operations Centre, and they say, hey, you might want to go and check how close you're maybe getting to this object that's happening into the future. And so these quite happen, and what we would want to do is we want to look at how that evolves over time as well. So in our operations centre, what we will then do is we'll have to perform our own analysis of the information we've received with respect to that object. What usually happens is that many operators that fly a GPS or have a better understanding of their position than is publicly known, allows us to then get a better and more precise idea on what is happening between a given conjunction. And this is kind of really important for a number of space operators. One, because you obviously want to make sure that you're operating in a responsible way. You want to make sure that you're working with then partners. And so, for instance, if we had a conjunction, for instance, with another satellite operator, let's say it was like a Starlink's one, which is kind of the biggest set of conjunctions that are happening at the moment.
Because there's a lot of Starlink going up there, and there's due to be more in the future.
And it's now way over 50% of most conjunctions now. If they happened, we would have to get in touch with them and say, hey, do you know what your actual position is? Do you know what your own variance is in your predictions of where you think you might be?
Yep.
And so we have to do those sort of note comparisons between each other to then understand as to whether or not this is a real risk or whether or not it's not. Because 5 kilometres is kind of a big area, but you can travel through 5 kilometres in the space of a second.
Right.
So that's what we have to do here on the ground, and then we might have to say and take a decision as to whether or not we believe a threshold has been met to then either fire a propulsion system or at least ask the potential partner as to whether or not they could fire a propulsion system if we don't have one.
I'm learning rapidly what spacecraft conjunctions are all about here at Surrey Space Centre. One of the terms I've heard mentioned occasionally when you're trying to work out whether a conjunction is going to happen and how serious it is something called covariance. Can you give us a sort of a dummy's explanation as to what that term means? Yeah,
so probably the easiest way to explain it is you start with the word variance. And of course what happens with the variance is we might have a value of a position, like say it's our vector to a satellite that we know, and that has a variance, and we talked about that with the ellipse. So that's the variance we might have in x, y, z. And the covariance is the variance with respect to another object. So it's the variance sort of a variance between two objects. And they can have a couple of different relationships. One that might be positive, where you might see the variation of a particular variable getting bigger as another one gets bigger, and so that becomes then usually then a positive covariance, or one then that might get negative. So as one gets bigger, the other one might get smaller. So we usually then see that in the form of a negative covariance. So that's kind of the sort of simple way of sort of thinking and looking at it. But it's essentially looking at the variances between two different variables. So we use covariance to then help us understand the ultimate variance when we then come to predicting orbits and conjunctions.
So in some ways it's a gauge of how confident you can be in your predictions, is that right?
I think in a loose way we look at, for instance, the root mean square of a covariance or the square term of covariances. There's lots of different ways you can use covariances, analytically and mathematically, to take sort of a sum and a mean of what those variances are, in the same ways that you use standard deviations almost. But it does give you then another way of then measuring it, because you actually want to have perhaps a stronger confidence, and the only way of doing that is you understand like the error of your error.
One of the ways you get notified of a conjunction is you get an email from someone like JSPOC or potentially from one of the other tools that's available. So UK Space Agency is developing one of those. We're calling it kind of Meridian to monitor my satellites at the moment. Do you get a lot of those? Does it depend on the orbit you're in? Would an operator working out in geostationary orbit get different conjunction warnings to one working in low Earth orbit? How does it work for you?
So when we get these emails, they're usually typically called conjunction data messages. So we call them CDMs, and inside those CDMs it has 140 different parameters that are estimated by the US sort of radar source services. And in LEO, usually what happens is they come in batches. So as you get closer to something, they start looking at it more. So they take more observations because they might believe that it might be a higher risk. So you might get sort of one every day or multiple times per day, but because a conjunction event, you need multiple observations to know whether or not it's real or not.
So the UK Space Agency is very concerned about doing the right thing with regard to the world and ensuring that UK operators responsibly use the space that's available to all of us, and they're working on a tool to enable UK operators to share data and also to share them with government stakeholders. You're working a lot with ESA, the European Space Agency. What are they doing in this regard to try and assist with space traffic control?
So ESA has started efforts on standardization, but they also have their own sort of pipeline on how they manage things. So they also get CDMs that come in from NASA and the Joint Space Operations Centre, and they ingest them together with their own information. I think the big difference between how ESA might behave compared to someone in the commercial world is that ESA have 44 satellites. And of those 44 satellites, I'm going to say a good half of them are interplanetary. So they don't necessarily fall under the same level of risk. Of course, they have a risk associated with that, and they need to do their own due diligence of what's happening with them. But a bigger operator like Planet Labs or SpaceX or OneWeb, those are the ones that I would pay attention to, because what norms and things come out of their own processes are going to be far more important to us.
So we've been here at the University of Surrey Space Centre with Dr. Chris Bridges, Reader in Space Engineering, who's told us quite a lot about conjunctions and space traffic control and what we can do to make the situation better. Thank you very much, Dr. Chris Bridges. It's been really good to talk to you today.
Thanks, Adam.